sun. What do we know about the sun? It's a star, a ball of gas, the center of the solar system. We know it gives us heat and light, and therefore life. This enormous dense ball of gas held together by its own gravity. 92.1% hydrogen, 8.7% helium, small parts oxygen, carbon, nitrogen, silicon, magnesium, neon, iron, and sulfur. But what is the sun other than a spinning star? What makes it so unique, so essential, so important to human existence and even human culture? To understand this, I'm going to start at the beginning. Some of the earliest documentation of the sun refers to it as a god. Many religions had names for the god of the sun: Horus, Surya, Amaterasu, Apollo, and many more. Early humans used the sun to track the seasons, marking the point that the sun set behind a particular hill or other feature, and evolving into obelisks and sundials. It was believed for more than 20 centuries that the Earth was the center of the universe, and that the sun and other planets orbited around it. This was known as geocentrism. From as early as 900 BCE, ideas about heliocentrism, the now accepted belief that the sun is the center of the universe and that we orbit around it, were emerging. However, for more than 25 centuries after its first mention, this idea was rejected as it conflicted with various religious and cultural beliefs at the time. In 1564, Nicholas Copernicus published On the Revolutions of the Celestial Spheres, just before his death. Although it was not accepted at first, other astronomers began picking up clues of its truth. Copernican theory caused a change in the calendar 18 years later. As we all should know by now, Galileo dedicated much of his life to disproving geocentrism. By observing the daily movement of celestial bodies, he proved the concept of a system that revolved around the sun. However, he was oppressed and silenced by the Catholic Church as his findings contradicted religious scripture. In Isaac Newton's Principia Mathematica, 1687, he described how the sun's mass would cause the planets to gravitate towards it, likening it to how the moon orbits the Earth. Another astronomer, Edmund Halley, used Newton's theories to predict that Halley's comet, spotted in 1682, would return again in 1759. By around the time that Halley's comet returned, heliocentrism had mostly been accepted. The Catholic Church removed the ban on heliocentric ideas, and it was eventually accepted almost completely by society and religion. Today, there is still much we don't know about the sun. Scientists still have questions about the sun, like what causes its corona to burn at an estimated millions of degrees Celsius hotter than its surface. It is suggested that the sun's magnetic fields heat the corona, or maybe that solar ripple waves do. Such waves are known as the Alfvén waves and transport energy from the sun into space. They are not yet fully understood by the scientific community. Observatories have found that the waves travel at around 14.5 million kilometers per hour. Although we might never fully understand the sun, we have evidence that our ancestors used it, even with their limited technology. Some ancient monuments were built to match perfectly with solar cycles. For example, Stonehenge creates a permanent marker to the midsummer sunrise and the midwinter sunset. Many Mayan structures also mark important dates using the sun. Mayan culture in general made use of solar cycles and occurrences. Today, the sun still plays a role in culture and society. As we are more aware of its scientific importance to life as we know it, we can fully appreciate it. Many present-day religions still include and worship gods related to and representing the sun. We constantly strive to learn more about the sun and its many mysteries. Now, to fully understand the sun's importance to life, we have to understand why it can do what it does. The sun has multiple layers with different names and different purposes. The core, the radiation zone; the interface layer, the convection zone; the photosphere, the chromosphere, the corona, and various waves. The sun is densest and hottest at its core. The heat causes atoms to collide constantly and break down. This creates energy that allows the sun and the solar system to exist. Life on Earth is supported by the energy let off by the sun in the form of heat, light, and rays. This is because Earth's life forms absorb this energy in the form through photosynthesis and by consuming lower life forms. Today, solar cells attempt to harness and use the sun's powerful energy as a renewable resource. It is theorized that other solar systems are capable of sustaining life because of the presence of a sun-like star. 72 possible siblings of our sun, known as solar twins, solar analogs, or solar types, exist within 50 light years from Earth. Just like our sun, they give off energy that is absorbed by orbiting bodies. This provides a possible life-sustaining environment. However, the presence of our sun can be damaging to life on Earth. Although the sun's energy is what allows us to live, it can be harmful. Overexposure to sunlight can be mutagenic and is related to the development of skin cancer, skin aging, immune suppression, and eye diseases. Also, the end of life on Earth as we know it is likely to be brought about by the sun. It grows brighter and hotter every day, and by 500 million years from now, it is likely that Earth will be too hot for human life. It is estimated that in 5 to 6 billion years from now, if the pattern continues, that Earth will be absorbed by the sun's growth, and taking into account the effects of global warming, we could be dead in human life could be impossible by 2 billion years from now. This is why we should take care of our planet, because currently we are only speeding up the process of our ultimate destruction. Fortunately, the sun will most likely not cause our imminent deaths any sooner than expected, as it will be at least 1.5 billion years until this theory is realistic. Unfortunately, the sun is also slowly melting away at our precious glaciers as we speak, most likely bringing a new age of life to Earth. In attempts to better understand the sun, multiple spacecraft and satellites have been launched into heliocentric orbit. The Pioneer space probes A, B, C, and D were sent out in the mid to late 1960s and measured solar winds, solar magnetic fields, and other solar phenomena. This helped us to understand such solar phenomena. The Helios spacecraft 1 and 2, sent out in 1974 and 1976, also measured solar winds and solar magnetic fields. The Solar Probe Plus, estimated for launch in 2018, will also measure these solar phenomena. Thankfully, the sun is currently non-life-threatening, and for now it keeps us alive. It gives us life as we know it, and life to our entire planet and solar system, if there is life. Although we might never fully understand the sun, just remember that the sun is what we have to thank for our existence. Thank you. Any questions? No questions? Okay. Thank you.